Hello everybody, this is Gustavo, exam coach. We have a new question about data sufficiency in the GMAT quantitative section. When we say that y is a multiple of 3 as part of this question, we're actually wondering whether the number y defined as an integer is or is not a multiple of 3. We know that x and y are integers prior to the question. What do we have about y as information coming from statement 1? It says that y equals the product of x times x plus 1 times x plus 2. Considering that x is an integer, x plus 1 and x plus 2 are the consecutive integers to x. So y is the product of 3 consecutive integers. What can we gather from this affirmation? If you're not so strong in arithmetic, you might just raise your hands in despair and say, wow, this statement allows for infinite possibilities for both the values of x and the values of y. Can I actually conclude whether in all those infinite cases, y will be a multiple of 3 or not? And you might feel tempted to say, okay, well, the truth is that statement 1 looks not sufficient. Say not sufficient because I don't really know whether y will be a multiple of 3 in all those cases. And so you would just proceed to statement 2. And since here you see that x is a multiple of 3, well, you can gather nothing about y because this statement doesn't mention anything about y. You cannot relate this information to y, and so the statement would look insufficient as well. Then, in a third stage, you would say, all right, I didn't know for certain whether y was a multiple of 3, but now that I know that x is a multiple of 3, and statement 1 points out that x is a factor of y, any number that is a multiple of 3, right, multiplied by other integers will yield another bigger multiple of 3. And in that sense, you would say y has to be a multiple of 3 if I put together the two statements, because y contains x as a factor. Say, for example, right, that x is 3. Then you say y equals 3 times 4 times 5. Of course, this will be a multiple of 3. If x were 12, then you would say y equals 12 times 13 times 14. And this would also be a multiple of 3. So it is sufficient, and then you feel tempted to go to this answer choice, C. The statements together are sufficient, but neither statement alone is sufficient. Okay, if you get to this answer is positively wrong. Why? Why is that? Because we made a mistake in judgment at the moment of evaluating statement 1 for sufficiency. The fact that x is undetermined, and so is y. And because of this indetermination, that we couldn't conclude whether y would be a multiple of 3 in all cases. But this reasoning is actually a fallacy. We cannot just conclude that because a statement seems too open or it tells nothing about what is being asked in the question for the statement to be not sufficient. What is the only criterion that you can use to decide whether a statement is sufficient or not? Actually, the definition of sufficiency. You need to make sure whether you obtain just one answer or not when you evaluate different possibilities for the variables involved in this statement. So, what a more cautious test taker would say. All right. It's true that this statement on its own doesn't seem clear in math terms to be or not something that I can use to say that y is divisible by 3 or not. But then again, what I can do is to try a few numeric values. My strategy is I will try as many values as I deem necessary to be satisfied that the statement produces a unique answer or not. Say, for example, what happens if x were 1? Then y would be 1 times 2 times 3. Is this divisible by 3? Of course. What about if x were 2? Okay, y would be 2 times 3 times 4. Is this number divisible by 3? Of course it is, because we're seeing 3 as a factor of this number. And then what happens if x were 3? Y would be 3 times 4 times 5. Again, an affirmative answer. And what about if x is 4? Y would be 4 times 5 times... All right, what do we have here? Another multiple of 3 as a factor that is part of this product. So the whole product has to be divisible by 3 as well. And then when we try some more values that are positive integer values for x, we realize that something interesting is going on. Y will always be a number that will contain a number or factor divisible by 3 as part of these 3 factors that make or compose y. So it is just logical to conclude that y will always be divisible by 3 because it will always contain an integer factor that is divisible by 3. And that is simply because all numbers divisible by 3 are separated on a number line, every 3 numbers. So no wonder that no matter which number we choose, for example, we say, okay, what about x equals 100? Then y would be 100 times 101 times 102. And 102 is divisible by 3. So the whole product has to be divisible by 3. Every time, as it is defined, y being the product of 3 consecutive integers will always be a number divisible by 3. So statement 1 is sufficient. Yeah, there's no discussion about statement 2. In a correct analysis of statement 2, we cannot relay this information at all to y. With statement 2, the only thing we can gather about y is just what was said at the beginning prior to the question, that y was an integer. So we know nothing about y to say for sure that y is a multiple of 3 or not. So statement 2 alone is not sufficient. But now the correct answer choice would be option A. This is the right answer choice after the correct analysis. Okay, so this is it. We are coming to the end of our video, and be careful every time you don't feel certain that a statement in a data sufficiency question is delivering coherent information to say whether there is an answer choice that is unique to the question above. You can try values. Try as many values as you consider necessary to feel satisfied that you are finding a unique answer to the question, or you are finding that there is more than one answer to the question. See you on the next video.